Live to YouTube. It's Tuesday, September 10th. Mr. Max Room. 4th hour. We're doing a moron day. And again, when I say moron, I don't mean you are a moron. Okay? What I mean is we're doing more on the last lesson. And really by more on today, we're not doing more on the last lesson. We're doing more on what you learned in 5th grade. Okay? That's what we're doing. Today we don't have any notes because it's a moron day. It's just for your health. For your health. Okay, Steve Brule. So here's what we're going to do. We're going to construct and measure angles. Hey, we did that already. We constructed some angles and we measured them, sort of. Oh, we should check mine. I'm really good at making nice angles on accident. Let's see. The first hour I did 25 without trying. The second hour I did 50 without trying. Let's see what this one is. Oh, just a little bit off. Just a little under 50. I nailed it the first 2 hours. Dang. Dang. But anyway, that's how you measure an angle. You put the little circle thing on the vertex, right? And you line up this line with one of your rays. And when that's in line, you extend this out and you see where it hits. You want the smaller number here because this is an acute angle, right? So 50. The big angle from here to here would be 130. Cool? Know how to use these guys? Ever used them before? Nah? Wonderful. Fantastic. We won't be using them for a while. All right. So we did that. Now we're gonna talk about regular polygons. So we need to know what regular means, Metamucil, and what a polygon actually is. We're gonna talk about convex versus concave, and perimeter and distance. And here's how we're gonna do it. We're gonna get a little worky sheety. We're gonna write down some notes on it because we don't have any notes today, and then we're gonna talk about these things as we go. Hold on. Don't pass it back. It's just thick with 3 C's. Okay. We're talking 6 pages here. 3 pages. Front and back. We're going to do one example together. There's only 5 total problems on here. Okay, sheet thick, but you don't have a lot of problems, right? Nothing wrong with that. You saw a chance, huh?
Yeah, he went to what?
Dipping, huh? The old swip and dip. All right. So, it says write the name of each polygon, which begs the question, what's a polygon? Well, let me tell you what a polygon isn't first. This is not a polygon, okay? This figure right here is not a polygon because it has 3 segments and every segment should connect at its endpoints. See how those don't connect at an endpoint? They connect at some other point? That ain't a polygon. In other words, you can't have open ends, right? So like this also would not be a polygon. Blowing your mind here, I know. The other rule is it has to have sides. So like the circle, we love it. It's great, but it's not a polygon. Oh no. Oh no. So a polygon is pretty much anything else. Triangles, rectangles, squares. You know them, you love them. They're polygons, okay? Name them. Well, I just did. I named some of them. Over here, let's write some of the popular names down, right? These are like Becky and John, right? Names that come up a lot. So triangle, you probably heard this one before. Very common name. Has 3 sides. Also has 3 angles. That's why we call it a triangle. There's only one way to do a 3-sided polygon, right? Every time it pops up as a triangle. So it's very specific. Whereas for 4 sides, there's lots of ways, right? You can make a rectangle, make a square, make a rhombus. Everybody loves a rhombus, right? Mathematical. We're going to call those quadrilaterals. Quad meaning 4, so it's a 4-sided figure, right? 4-sided polygon. Lateral means side. That's going to come back. Lateral means side. Like when you look at the lateral portion of somebody, you're looking at their side view, right? I'll zoom in. I don't need to squint. Okay. You guys need a day to all go to the eye doctor together. Forget the braces day, okay? That was so like adorable and weird at the same time when like all of you guys were gone. It's like, where are they gone? Oh, they're getting braces together. Aw. Did you guys get matching rubber bands? That's what I would have done. Get t-shirts maybe. All right, 5-side pentagon, which is Satan shape, which is ironic because you think it'd be the hexagon because that's 6-sided and it has hex in it, which sounds very satanic, but it ain't for some reason. 7 is the septagon, or at least that's what I call it. I don't know if it actually is. Typically people just say 7-gon because it has 7 sides. Like a 99-gon would be a 99-sided polygon, right? 8 has a special name. You know it. You love it. It's the stop sign. We call it an octagon. UFC fans know what I'm talking about. 9-gon, which it's fun to say. 9-gon. 9-gon. It's just a lot of N's. 10-gons have special name. We call it a decagon. Like December, how it's the 10th month of the year, right? Then we have 11-gon, boring. 12-gon has a special name, dodecagon. Do meaning 2, dec again meaning 10, because December is the 10th month of the year. So 12 total. After that, we just call it like a 13-gon, 14-gon, 15-gon, you know. There's probably names, but who cares? So, pop quiz. Which one is this? Pentagon, because it has 5 sides. Then it says, tell whether the polygon is convex or concave. So here's convex and concave in a nutshell, okay? This is a concave polygon. You see how it caves in? That's concave. Convex, on the other hand, doesn't cave in. So convex is more like a contact. You wouldn't mind sticking something like this in your eye because it pushes outward, right? Your eye would sit right in there, no big deal. Concave, that would be painful because it's pushing back into your eye. So concave caves in, convex does not. Another way to think of it, internal means inside, right? Like inside voices, internal voices, which is what I hear all the time, but I just ignore them. If you look, the angle inside here, that internal angle, is greater than 180. See that reflex angle right there? We have an internal reflex angle, which means it's concave. See how these guys are all less than 180? Internal angles? Some are bigger than 90, but they're all less than 180, so that's convex. This guy over here, convex or concave? Well, look at this angle. Is that bigger than 180? No, it's not. What about this one? It's bigger than 90. Is it bigger than 180? Remember, 180 is a straight angle? No. What about this one? Bigger than 180? No, otherwise it'd be a straight angle. Bigger than 180? No, it'd be a straight angle. It's not, right? Bigger than 180? No. So this is convex. All these sides are pushing out, right? Not pushing in. So convex for this one. And mark congruent segments. Congruent means the same length, right? So, which ones are congruent? How are we going to figure that out? We need to measure them, pull out the old protractor, and no. We are men of science. What we're going to do is use distance formula. And distance formula is just the same thing as what? Oh, come on. Distance formula is the same thing as what? Pythagorean theorem, right? Pythag. So if I were to draw a triangle right here, a right triangle, like that, and I know that is 4 across and that's 3 across, can't I find out how long this is? Pythag says 3 squared plus 4 squared, rooted, right? What's 3 squared? 9! What's 4 squared? A fun game to play outside. When we add those together, we get 25. The only thing funnier than 24. When we root 25, we get 5. So that has a length of 5. Now, you probably should have this memorized by now just from doing it so often. 3, 4, 5 is a special Pythagorean triple. You see a 3 and a 4 as legs. 5 is going to be the hypotenuse every time. Check it out. What about this guy over here, ED? Well, that's a 4. That's a 3. So how long must ED be? 5. So put 2 little tick marks there. 1 and 1, right? Because they are congruent. Mark them. What about the other ones? These look like they might be congruent. They're not, but they might be. Who knows, right? I don't know. If we draw a triangle in here and here, we get 6 for this side and 8 for that side, right? Oh man, that's not a special right triangle. We only know 3, 4, 5. What do you notice about a 3, 4, 5 triangle and a 6, 8, whatever triangle? Take your time. 6 squared is what? 36. What's 8 squared? When we add them together and root them, we get a root of hundo. What's root of 100? 10. So it is a special right triangle. Notice that a 3, 4, 5 triangle, if you double all the sides, you get a 6, 8, 10. It's the same thing. Hooray! So if we tripled them, 9, 12, 15, that would be another 3, 4, 5 triangle, just a bigger version of it, right? So those are nice triangles. There are other numbers you can use, like 12, 5, and 13 are another Pythagorean triple. And 12, 5, and 13 isn't just a bigger version of this. It's a different right triangle, right? There's no way to multiply them all to make them 12, 5, and 13. So that's 10. Is this one 10? Oh, boy, I hope it is. 1, 2, 3, 4, 5. Oh, nope. I always do this. 4 across. Looking promising. Are we going to get a 3? Nope. 1, 2, 3, 4, 5, 6. Well, that's okay, though, because if that's 4 and that's 6, I just doubled one of them, right? Turns out it doesn't work that way. You have to double all the sides if you're going to double one of them, right? So this is not going to be a nice right triangle. What is it going to give us for a side here? Well, what's 6 squared? 36. What's 4 squared? A fun game to play outside. When we add 36 and 16 together, what do we get? Well, 36 plus 10 is 46. 46 plus 6 is 52. Root 52. So that's how long that is. Sounds like a fun place to drive. But it's not a rational root. It's irrational. It's a decimal that goes on forever and doesn't repeat, right? Cool. So only sides that are congruent are BC and ED. We will write that BC, the segment, is congruent to ED. Let me zoom out. There you go. Then it says, use the distance formula. Well, we did. We just used PFAG because we smart. And then write the perimeter. Well, the perimeter is the outside length, right? So P for perimeter is going to be all these lengths added up, right? Root 52. Oh, this one right here. How long is AE? How can we figure that out? How can we figure out AE? It's 4. How'd you figure it out? You counted the squares. Isn't it nice when they're perfectly horizontal or perfectly vertical? It's so nice, right? So we have 4 plus 5 plus 5 plus 10 plus root 52. Pop quiz. Which is bigger, 10 or root 52? Think about it. Yeah, Mark. 10. Why is 10 bigger? Got him, Hannah.
100 is bigger than 52.
Yeah, root 100 is 10, right? And root 100 is bigger than root 52. You see what I'm saying? Like, you can think of them both as roots, and then you can go from there. That's a tough one, though. Nice job. Not bad, Mark. All right. So how do we add this up? Well, just like in real life, you just do as much as you can. You can't do more than that, right? Well, I can add 5 and 5 and get 10, and I can add 10 to 10 and get, and I can add 20 to 4 and get 24. But I can't add root 52 to it, so I just keep it like this. Right? If you want to plug root 52 in your calculator and then round it, knock yourself out. But my answer is exact and your answer is rounded. Why do extra work to be less exact? Right? Circle the dumb thing. Welcome to being a real mathematician and not a third grader. Okay? We did it! Yay! We named it. It's a pentagon. We found the side lengths. We said which ones are congruent. We called it convex because it is. Another way to think of convex is if you extend these sides out, none of the sides would extend into the interior of the pentagon. They would all stay on the outside, Whereas opposed to number 3, if I were to extend that guy, see how that would go through the interior? So that's concave, right? Also, that's a reflex angle on the inside. Definitely concave. We found the perimeter by adding them up, and we wrote the things down that we knew. Yay, writing. Let's talk about regular. What it means to be regular, okay? Metamucil, fiber in your diet. That's not what we're talking about. Look at number 6. A regular pentagon implies 2 things. 1, equidistant, or not equidistant, sorry, wrong equa. Equilateral, what does it mean to be equilateral? All sides are equal. Lateral means side, right? It's a Latin word for side. Equal means equal, right? Equilateral triangle has all the same sides. It's a coincidence that triangles that are equilateral also have equal angles. Okay, so often we think they're one and the same. They're actually two different things. Equilateral only implies the sides. Equiangular implies the angles, right? So regular means all the sides are the same, all the angles are the same. Okay, it's both. So it says draw an example of a convex regular pentagon. Convex means it doesn't bend into itself, right? You don't need to have it be exact to scale. So just draw something with 5 sides and label the sides. If I asked you to draw a convex regular triangle, well, I would draw 3 sides poorly. I would tell you all the sides were equal, and you'd have to believe me because I told you it was. And then I'd tell you all the angles are equal because, again, if I say so, it is. So don't try to bust out the protractor and get a perfect pentagon here. That's not what I want. Just label the sides and say they are. Dig? Number 7. Can you ever have a concave triangle? If yes, show me the example, right? That's a really easy way to prove something is possible. Show the example, right? If not, conjecture as to why that's not true. Okay? Figure that one out. Number 8 is self-development. It says for 2 points. And again, self-development is optional. You need 10 points before the end of the year. Get them where you want them. It says prove that a polygon cannot be both regular, remember equilateral and equiangular, and concave. So all the sides are the same, all the angles are the same, the internal angles, right? Why can't it also be concave? Hint, what do you notice about the angle relationships as you go from convex to a concave polygon? Other hint, does the number of sides matter? It don't, because if it did, we'd have to prove it for every single possible polygon. And how many possible polygons are there? Infinitely many, right? We can have an 8-sided polygon, we have a 9-sided polygon, we have a 10-sided. So prove it for a quadrilateral, right? If it works for a quad, it should work for anything. Quad's the easiest one. Why can it both be concave and equilateral / equiangular? Remember, equiangular is talking about the internal angles all matching up. No yawning in math class. Questions, comments, concerns other than from a mental well-being? No? Fantastic. That's your homework. Number 5, BC is connected. It looks like it ain't, but it is. These are all polygons, so they're connected. Just that line for the outline of the graph was thicker than the line for the line of the figure. 3C versus 2C here. All right. That's it. Test Friday over all the stuff we've done before and this. Lots of definitions, right? Reflex angle, all that crap, which are gimme questions. You don't need them to think about it. Which is why there won't be many definitions on it. Only some of them.